Hello guys, Cristiano here. I am a C programmer, learning all those things that I can. Hit the subscribe button, let a comment, that'll help so much the channel. All my videos, you'll be in a fast mode with explanation. I'll reduce the time to be more precise. And you'll face a lot of mistakes and debugs. Everything's calculated, or not. So don't be afraid. The link for all the source codes will be in the description. If you wanna follow, just get your copy. In this video, you are introducing Kafka to SIT. This opens up the possibility of creating projects using event-driven architecture. In future videos, we'll have projects where we already use this implementation, so stay tuned. We start by adding the option to enable Kafka. We include the rules for its compilation. We create a file with the rules to include the source and includes for the compilation. Here we check for dependencies to proceed with the build. This is something I want to do for other features as well, and inform the user if certain libraries are missing to continue the build. Now we create these SIT Kafka files, include the source and the header. We also created folders to group the Kafka files. This implementation includes several files. It is important to group them. This will help me in the future to refactor and separate them into two groups. The first header is the Kafka message, which contains a structure to define the message key and the payload. Next is the interface. This part doesn't look good. It is on my list for improvements. Here we have the interface that will be filled by consumer to receive messages. Next is Kafka topics, which receives a list of topics to register. The next is Kafka groups, which also receives a list of groups. Next is Kafka common, which holds the configuration group parameters. Finally, Kafka configuration, that loads the properties for the client configuration. It doesn't look if it's a consumer or producer. We define the client types, producer or consumer. We define the context and arguments for the client parameterization. We continue with the creation of the functions, init, open, send, pull, and close. We adjusted some signatures. We will implement the Kafka load group. This code does the following. For each group, a list is formed with the parameters, and for each parameter, the value is assigned to the configuration context. Now the configuration load and unload. In load, the group is passed for a parameter reading. In the unload, we set the pointer to null. After finishing the support functions, we can proceed to implementations of the resource usage functions. We implement the boilerplates and adjust the messages. At this point, I have several implementations, but redoing this makes me realize the need to create something to automate this creation. In init, as always, we clean the context. In the open, we need a few steps to start. We create an instance for the configuration. We use a do while loop to facilitate breaking in the case of failure. In load, we pass the file and the groups to be loaded. We create an instance with an instance create using the configuration, then we configure by type. Lastly, we call the configuration unload. Now it's necessary to create the functions. For that, we will create the prototypes. We create with the instance create. Here we got the client type, and based on the type, the instance is created. If it's valid, it returns true. Next, we need to create the getType function. GetType is simple. Here I assume it is a producer. If it is a subscriber, then the type is changed. Now, configure by type. The configuration depends on the type. If it is a producer, we set the callback to display an error message in case of sending error. If it is a consumer, we configure the topics to register and set the handler for when messages arrive. Here, we generate two more functions, and we will create the prototypes. There is also the function for the callback for sending errors. In the topic subscription, we create a list with a number of topics. Then we add all registered topics to the list. Then we register using the list. After that, we can destroy the list. In Set Records Handler, we assign the interface to the context. Again, this part is not so great. In callback publish on error, we display the error messages on the terminal. Here we could have used login. Moving on to send, we need to ensure that the instance is a producer. So we check if it is indeed a producer. We check if its topic is not new. We also check if the message instance is valid. With everything set, we prepare the message to be sent. We do not wait for the messages and perform a flush. In the poll function, we check if it is a consumer. We wait for a message, and if it is valid, we check if there was an error. If there was no error, we process the message and then free the resources used by the message. Two more functions were generated. Let's create their prototypes. In each message error, we check if the message is valid. Any processed message, we check if the interface was filled and convert the Kafka message to our message. This completes the implementation. Moving on to the tests, remember, Kafka also needs a container providing the broker. We already have a Docker Compose file with this implementation. We need to file to configure the clients. We created one with a broker address and the parameters for the consumer to consume from the beginning along with the group. We adjusted the CMake by passing the directory where the Docker Compose file is located and the file as arguments for the test application. In the test, we include the necessary headers. We define the indexes for each argument. We create a prototype for a function that will be called when there are messages to process. The test will have two threads, one for the consumer and another for the producer. In the main function, we create variables for the threads and get the arguments to change to directory where the Docker Compose file is located, as well as a configuration file, and we run the broker. We create the threads, pass the configuration file as an argument. We retrieve the file in both threads. For the producer, we configure each group will be loaded. We pass the file on the list and set the type as a publisher. We clean the context with init and we configure it with open. We configure the message and the message key. We send messages to the purchases and the quick start topics. It will send every half second. We close the producer. We reuse a part of the producer configuration for the consumer configuration. We add another group to configure the consumer. We create a list of topics. We change the type to the subscriber. We add the interface. This part is really not great. We parameterize with init and open. In this case, we call pull to start receiving messages. We fill the interface to print the received message. As soon as message is received, the test ends. Finally, the close function. We check if it is the type subscriber, because the consumer have a special treatment. Lastly, we destroy the instance. We enabled SIT Kafka and we start the compilation. We forgot to add additional headers. In fact, we used the wrong instruction. We compile again. I forgot to add the test. A small error with the same column. We use columns. Compiling and testing. And everything is okay. The SIT library has expanded its horizons with the integration of Kafka, a powerful distributed streaming platform. This groundbreaking addition opened up a plethora of opportunities for developing event-driven architectures and real-time data processing applications. That's all for now. I appreciate it if you get here. Don't you forget to hit the subscribe button, leave a comment and share. Knowledge is not enough. Waiting for more. Bye. See you soon.